Hello everyone, welcome back. I am Mr. Cobalt and today we are going to go over how to use density as a conversion factor. And at the end of this video I will talk more about how you can use other things as conversion factors as well, not just density. So whenever you have a word problem like this, the way you want to begin is to pull out the information that you need, that the problem is giving you. And the information that you are looking for is specifically relationships between two different things. And a lot of times they'll say things like this per that, or miles per hour, grams per milliliter, things like that. Anytime they say something per something, that is a conversion factor. That is a relationship that you can use to convert. So that's the first thing you want to do is pull out those relationships and ignore everything else. And then the question. The question is where they're going to tell you where to begin in your problem and where to end. And those are the things you need to know. So if you know where to begin and you know where to end, and you have your relationships to use as conversion factors, the conversion factors will get you from the beginning to the end of the problem. Okay, a lot of problems will have fluff, information that is not really going to be useful at all, right? So this is a good example of a problem that has some information that is not useful. So let's go ahead and get into this problem. Okay, so the problem begins. The mass of fuel in a jet must be calculated before each flight to ensure that the jet is not too heavy to fly. Okay, that first sentence had no useful information at all. It's nice to know. Okay, that's cool. But not going to be useful for solving the problem. A 747 is fueled with 173,231 liters of jet fuel. Okay, that is a piece of information that is going to be useful. So notice that this is not related to anything else, right? So it's not relating the liters to some other unit or some other thing. All it is just saying, okay, we're going to add that amount of fuel to the jet. But that is useful information. So we can write that down. So 173,231 liters. So what are we going to do with that? Okay, keep reading. If the density of the fuel is 0.768 grams per centimeters cubed. Okay, stop there. We have something per something. That is going to be a relationship. That's going to be that's a conversion factor right there. So let's write that down. So that is telling us 0.768 grams of the fuel is equal to 1 centimeter cubed of the fuel. So this is equal to this. So we can use that as a conversion factor in this problem. So let's keep reading. So now we're going to get to the question, what, and again, the question is going to start with some sort of question word, and whatever follows the question word is going to be where you end. Okay, so what is the mass? Okay, so we're going to end in a mass. What is the mass of the fuel in kilograms? So we need kilograms of fuel. That is where we're going to end. So I draw my arrow. So we're going to end with a certain number of kilograms of the fuel. Well, where are we going to begin? Okay, we're at the end of the question. So the question is supposed to tell us where to begin. In this case, it doesn't. Okay, so it's not always going to tell you where to begin and where to end together. It did tell us where to end. So now we got to figure out where we're going to begin. Okay, we want to know the kilograms of the fuel. Okay. what are we going to begin with? We're never going to begin with, I shouldn't say never, but 99% of the time, we're not going to begin with a conversion factor. So this relationship, we're not going to begin with the relationship. We're going to use that to convert. So the only other piece of information they give us is the volume of the fuel. So they give us liters. That's going to be where we're going to start. Again, 99 times out of 100, we're going to begin with the information that only has one unit. Notice that the density here has 2 units, grams, centimeters cubed. We're not going to begin with that. So the information they gave us that has 1 unit, that's most likely where we're going to begin. So that's usually a good indication that we're going to begin with this. So we need to start with the 173,231 liters, and we need to get to kilograms. Okay, so the rest of the problem is going to be where we're start here, and we're going to use our conversion factors to get to kilograms. Okay, so let's go ahead and get this started. So I'm going to write down, I'm going to set up my problem, 173,231 liters over 1. And so now I need to get the liters, and I need to convert so I can use my conversion factor. So I have liters here. It's a volume. My volume unit here is centimeters cubed. So I need to convert to get to centimeters cubed. So I know that 1 milliliter is equal to 1 centimeter cubed. So I want to use that. So 1 centimeter cubed is equal to 1 milliliter. So if I can use that, if I can get to milliliters, then I can use milliliters to convert to centimeters cubed, and then I can use my centimeters cubed to grams to convert to mass. So let's go ahead and do this. So my first step is to get to milliliters. So I need my equality between liters and milliliters. So again, when I'm setting up the equality for my metric units, I'm relating my prefix unit with the base unit. I put the 1 always with the prefix. Why? Because then I replace the prefix over here with the prefix multiplier. So milli is the prefix. The multiplier for milli is 10 to the negative 3. So 1 milliliter is equal to 10 to the negative 3 liters. So now I have my equality. So let's use it. So I have liters on top, so I'm going to put liters on the bottom. 10 to the negative 3 liters, 1 milliliter on top. Okay, so now liters cancels out. Now I have milliliters. So now I can use my 1 milliliter to 1 centimeter cubed. So that's going to be my next conversion. So milliliters goes on the bottom. So 1 milliliter goes on the bottom to cancel. And then 1 centimeter cubed goes on top. So milliliters cancels out. Now I'm done with this one. I'm done with that one. So now I can use this relationship. I can use 1 centimeter cubed to 0.768 grams. The density that I got, I'm going to use the density as a conversion factor. So now I take the 1 centimeter cubed, put it on the bottom, and now I take the 0.768. So 0.768 grams of the fuel. So now centimeters cubed cancels out. Now I have grams, I have mass, but I'm not done because it's asking for kilograms, not grams. So I need to keep going until I get the unit they're asking for. So now I need to convert grams to kilograms, so I need that metric relationship again. So once again, I'm going to relate grams to kilograms. I'm going to put the 1 with the prefix, so 1 kilogram, and I'm going to replace over here the multiplier for kilo, which is 10 to the 3. So now I have my equality that I can use as a conversion factor. So now I'm going to do my last step. Grams goes on the bottom. I have 10 to the 3 grams. So 10 to the 3 grams of the fuel goes on the bottom, and 1 kilogram goes on top. And so grams cancels out. I now have kilograms. So that is what the problem is asking for. That's where I'm supposed to end. I stop. Now I just take my calculator and I calculate the answer. So really quickly, I'm going to multiply across the top, divide by the bottom. Ignore the ones. You don't need to worry about ones. So 173,231 multiplied by, forget the ones, 0.768. Okay, now I'm going to divide. So I'm going to divide by 10 to the negative 3. And then divide by 1,000 equals, and the answer I get is 133,041. So 133,041.408, and that's kilograms of fuel. So this is what the calculator gives me. That's the answer, but I'm not finished. I have to figure out the number of sig figs that I'm allowed to keep. So now I go back to where I multiplied and divided, and I ignore anything that's exact. So here I have kilograms to grams. That's an exact relationship because I have metric to metric relationship of mass. Here, this is a measure because I have volume to mass. That's a measure. Here I have milliliters to centimeters, metric to metric. That is true by definition. That is exact. Milliliters to liters. That is true by definition. Metric to metric. That is exact. And their volumes. A volume, metric volume to metric volume. And here is what they gave me. That is a measure. So here I have 6 sig figs, and here I have 3 sig figs. So my answer can only be in the least number of sig figs that I multiplied and divided by. The least number is 3, so I'm only allowed 3. So 1, 2, 3. I cut it off here. I keep the 1, 3, 3. Now students, sometimes they will just keep the 3, 3, 3, and that's it, and then forget the rest. But look at this. This is 133,000, not 133. So if I drop these, I need to replace them with zeros because those zeros are placeholders. Okay? So without the zeros, I get a different number. So then the number is going to be 133,000 kilograms of the fuel. So, and then you can write that in scientific notation. 1.33 times 10 to the 5 kilograms. And so that is the answer. The great thing about scientific notation is that it automatically has everything in the proper number of sig figs. You don't have to worry about the zeros. So again, you can use density as a conversion factor anytime you have a relationship of something per something. Meters per second, miles per hour, grams per milliliter. That can be used as a conversion factor. I hope this was helpful. Like the video, subscribe to the channel, make a comment. I'll see you next time. Thank you.